Okay, 7.1, roots and radical expressions. So for starting off, some of this will be review and some of this will be new. We say since 5 squared is 25, 5 is a square root of 25. Right, we already know that. At least I hope so. 5 cubed is 125. So 5 is a cube root of 125. Right. And lastly, I want to say that 5 to the 4th is 625. So 5 is a 4th root of 625. We normally have a fancy word for square, a fancy word for cube. There are fancy words for the 4th and 5th roots, but normally I'm just going to call them 4th and 5th roots. Nth root. We have the nth root. And this is actually kind of a theorem definition. We say for any real numbers A and B and any positive integer n, if a to the n equals b, then, if I can spell correctly, then a is a nth root of b. Okay, that is basically just the written version of what I said earlier, right? After we get to the 4th, we just call it the nth root, or the 5th root, the 10th root, the 20th root, right? All right, moving on. Now we have a little chart that we're going to make. We have the type of number. We have the number, here I'll use the pound symbol, number of real nth roots. And here we have the number of real nth roots where n is odd. Right, so it's going to make a difference if n is even or n is odd, right? Think about a cubed root versus a square root. Most of this I think you could have worked out in your head. So here we'll have a positive number. We'll have 0, and we'll have negative. All right, so now I'll cross out and make our little chart here. All right, so starting off in the upper left corner here, a positive number where n is even. It will have 2 roots, right? An example of that would be like 4 squared, right? 4 is positive and 2 is even, okay? That's what I'm meaning by there. Now, a positive number with an odd exponent will have a 1 root, right? Think about 4 to the third, or here's a better example, 8 to the third. 8 to the third only has 1 root, being 2, 1 real root. 0 will have 1 and 1 of each. right? The square root of 0 is 0. The cubed root of 0 is 0. Now, whenever we're talking about negative numbers, right? Think about negative 4 squared, or better yet, I think I should write it like that, the square root of negative 4, right? That doesn't have any real roots. But a cubed root will have 1, right? If you say the cubed root of negative 8, you'd end up getting negative 2. All right, let's do some examples. Number 1, cube root. We're going to find the cubed roots of 0.008, negative 1,000, and 1 over 27. You know what? I'm just going to write them as cube roots like that. All right. You can type these in your calculator, or you can just kind of think them through. To start off, I'm just going to type these in my calculator. So I'm going to type in 3, and on my calculator, I have to do second caret. They're all different though. So if you don't know how to do that, go ahead and look on YouTube to see how to do that. 0.008, that gives me 0.2. Right? And I don't have to worry about a plus or minus there because there's no, like, negative 0.2 would give me negative 0.008, right? Now for negative 1,000, that's going to be negative 10. 1 over 27, the root can break up over the fraction bar, so I have the cubed root of 1 and the cubed root of 27, so I have 1 over 3. All right, let's look at the next one, number 2. These are the fourth roots. Starting off, how did I write that? I wrote it differently than there. All right, starting off, I'm going to do 1, then we'll do negative 0.0001, and then we'll do 16 over 81. And I should write these as fourth roots like that. All right, there we are. So the fourth root of 1, what to the fourth would be 1? And that could be positive or negative 1, right? So I'm going to say positive and negative 1. One way to think about that with that negative is if you have negative 1, negative 1, negative 1, negative 1, four negative 1s, right, because we're in the fourth root. These two would cancel and give me a positive. These two would cancel and give me a positive. So now just 1 times 1 is 1, right? So the positive and the negative have to be accounted for there. Part B, we get 0.0001, and it's negative. Well, there is no answer for that. Right? You can't have a negative number under an even root. Right? And that goes along with what we did up there. Right? If we ended up having just 3, we'd end up having 1 and negative 1, which would be negative 1, right? So that wouldn't work because you couldn't end up with that. All right, part C, we'll break it over the fraction bar, so I'll have root 16 over root 81, which is going to be 4 over 9. And I have to put a plus or minus there because even though it's a fraction, it's still a regular number, right? It's a positive number under an even root, so I have to have the plus or minus. So this will give me 2 over 3, plus or minus 2 over 3. All right, I'm not going to do square roots because I think that we probably know square roots. All right, now a lot of the time we talk about just the positive root, right? If we have a square root, a lot of the time we just talk about the positive one. That's going to be called the principal root. principal root. All right, principal root. When a number has two real roots, the positive root is the principal root. Big deal there is the positive root, okay? So whenever I'm talking about this, an example of this would be that for square root of 4, 2 is the principal root. Okay. All right. We have a couple definitions more. The radical. That is the number under the root, or you could write it like that. The number that's under there is the radical, right? So in my example up there with the square root of 4, 4 is the radical. Then we have an index. Index is it's the little number in front of the root, or in front of the radical, in front of the radical sign. And what we're talking about there is whenever we've got a little root there, that is the index. Okay. Here I could put like a 4 there. That is and this is the root or radical sign. Normally I will call it, or I'll reference it as being the root, or I'll call it the radical sign, right? Normally I like to call it the root because radical is already another term, right? All right, let's move on. This is a property of this. This is the nth root of a to the n for a less than 0. Oops. For any real number, excuse me, it's for any negative real number. For a negative real number, and we'll call it a, then the nth root of a to the n is the absolute value of a when n is even, okay? Now that can be confusing sometimes. Why is it the absolute value, right? Why is it not just a? Well, here's the way that I like to think about this. If we have, how do I want to say that? If we have the square root of, we'll say, -2 squared, okay, versus the square root of 2 squared, okay? They're the same but different. Starting off working on the inside of that root, this would be the square root of 4, right? Whenever I square that negative, it goes away, which gives me 2. The bottom piece, I'd say, well, this is the square root of 4, which gives me 2 again, right? They end up giving the same thing. So that's why we have to use the absolute value. So we could have just jumped straight over here and say, well, it's the absolute value of -2, which is 2. On the bottom, we'd say, well, this is the absolute value of 2, which is 2. Okay, that might be useful to show you how to do that. But we do need to use these absolute value bars, and you will have to do that on the homework. All right, moving on. Let's do some examples. Let's start off with the square root of 4x to the 6th. Now, I know that I've done some of these with you before. We're talking about the square root. We might want to put that little square sign in there, or the little 2. We're looking for pairs of items to go outside the root. So 4 splits up into 2 and 2, so that can go outside the root. Here, let me change colors. 4 splits up into 2 and 2, so the 2's, a pair of 2's, can go outside the root. The x to the 6th. X to the 6th is like 2, 3, 4, 5, 6 x's, and I can have 3 pair, right? So I have 3 x's on the outside, so it'll be 2x cubed. Number 2. The cubed root of a to the 3rd, b to the 6th. All right, so starting off looking at the a's, we have a cubed and a cubed root. So a can come outside, and it'll just be a single a. B to the 6th will be 2 trios of b, right? 2 sets of 3 b's, or 1, 2, 3, 4, 5, 6. I have my left 3 and my right 3. So I'll have 2 b's, which is ab squared. Number 3, the 4th root of x to the 4th, y to the 8th. Using the same idea as last time, we can say that this is going to be xy squared. Right. Now really, let me go back here and just look for just a second. Really, I missed something back up here. On number 1, we should be saying this is the absolute value of x. I'm sorry. That's the absolute value of x cubed, right? Because we have an even root and an even exponent, right? So it falls into this rule here. I apologize, I missed that. On this one here, x to the 4th and the 4th root of x, we have to have an absolute value bar around our x. Now our y, we don't care about the absolute value bar because y is going to be squared, so it's going to make it positive anyway. You could write the absolute value bars in if you wanted to. All right, number 4. Number 4. Do the square root of 4x squared y to the 4th. Well, the 4 is easy enough. The square root of 4 is 2. X squared, the root of x squared is going to be x, but we have to do absolute value bars. Y to the 4th with a root is going to be y squared. And we could use the absolute value bars, but we could just drop them too. So we could say 2 absolute value of x, y squared. Right? Either of those answers is good. Number 5. We'll say the cubed root of negative 27c to the 6th. Now, because this is not a even root, right, because it's an odd root, it's a 3, we don't need to worry about absolute value bars. So negative 27. Well, the cubed root of 27 is 3, so negative 27 is going to be negative 3. And then c to the 6th, there will be 2 trios of c's, so it'll be c squared. All right, we'll do our last example here. We'll do number 6. let us say the cubed root of x to the 4th, y to the 7th. And let me change this back to the correct color. Oops. All right. This is where it kind of is helpful, I think, to write them out. This is the same thing as the cubed root of 1, 2, 3, 4 x's and 1, 2, 3, 4, 5, 6, 7 y's. Now I understand that you're not going to do this every time. I'm just going to do it for a couple of them, or well, just for this one. I'm looking for sets of 3. So I have 3 x's, 3y, and another 3y. So I have an x that comes out front, 2 y's that come out front, and then I have some still stuck under the root. I'm going to have x and y, a single x and a single y. So there we are. The trickiest part of this lesson will be these absolute value bars, right? You gotta watch out for those. Remember, it's only whenever you have an even root, right? So even another example of something that you might have to look at here is if you have like the square root of x cubed. Well, this will be the absolute value of x root x. Now let me show you why that is. This splits up and I'd have, well, root x squared times x, which is the same thing as root x, let me make my root different, x squared times x. And right here, we have a piece that falls under that, I don't know, that theorem, whatever we want to call it, right? Root and then x squared has to have absolute value of x. And then we have our root x, okay? So kind of think about that. If you missed that on the first homework, I'm not going to take off for that, but think about that and get used to that. So, all right, email me if you have any questions.